Perfect. So let's get started with our regular expressions or our regex workshop. Um, it's a handy tool that um, will make your DH work in general easier and your LEMDO work in particular much faster than it would be without. Before we get too far into it, I would like to introduce myself. I know quite a few of you here today are new to our LEMDO workshops, so you might not have seen my face before. This is me. I'm Navarra. I use they, them pronouns, and I'm the project manager for LEMDO. I've been working with the project for about 3 years, and I'm lead trainer right now with the project. I'm also co-author of our documentation on regular expressions and have been training people in regex for about 2 years now. So hopefully I have some answers to questions. Hopefully I'm able to make this maybe a more approachable topic than it has been in the past. If you have questions, please let me know. Outside of my work life, I'm into quilting. I'm really excited to be starting on a new project right now as soon as the Internet Archive is back up and my pattern is available again. So I'm somebody who likes to have something to do with their hands all the time, quilting, knitting, all that kind of stuff. And with that being said, if you're also one of those people who likes to fidget, craft, move around, draw, take notes during webinars, please feel free to do that. I also want to start off with a territorial acknowledgement. We acknowledge and respect the Lekwungen, Songhees, and Esquimalt peoples on whose territory the university stands, and the Lekwungen and Wasanich peoples whose historical relationships with the land continue to this day. These are our learning objectives for today. I feel like this kind of condenses it all quite nicely into 5 small bullet points. But by the end of today, you should have a basic understanding of what regex is. You should also be familiar with and able to recall some key characters that we use in regex find and replaces, such as the period, the question mark, the $sign. And you should be able to create some regular expressions following the correct syntax. Finally, you should be able to find and use some resources, including LEMDO's documentation, which includes our preformed regex list, and some external learning resources. And I always put that in here on the regex workshop because this might be totally new information, and having a page that tells you what you're looking at makes it a lot easier. I will also note here, I tend to say regex. Some people say regex. There's not a correct or incorrect pronunciation. It's the same deal. It's an abbreviation of regular expressions. So we'll begin with an introduction. What is regex and why do we use it? Really simply, regex is a way of searching for things. It's a syntax of search patterns that we use to run complex find and replace actions, which we can do either in an individual file or across folders. So if you're looking for something, but it's not always the exact same thing, you'd use regular expressions. And what that looks like in practice is a string of characters that describe what you're looking for. This can be as simple as typing literally what you're looking for. So typing in DOG if you're searching for the word dog, or it can be more complex. In the find and replace window I've got open on this PowerPoint, I've added a more complex regex that we can use to remove old facts attributes from PB elements, which is something that we've done fairly commonly in the LEMDO ecosystem. All of these characters just say, look for PB elements with any facts attribute whatsoever. So because we can search for many things all at once, we can say, yeah, look for something that has any attribute. I don't know what the attribute is. we can find all of those things at once and make changes all the way across a file or across a folder or even across the entire LEMDO project. So Regex is a really useful tool when we're remediating a file, but it can also be useful when you're initially encoding a file. Using the same find from before here, I've added a replace that looks really simple. It just means that when I click replace all in here, my file keeps all of the PB elements and removes any facts, attributes, and values. So it's pretty useful, just one click of a button, and I've removed all of the attributes that I don't want on this particular element. And that's why we use it. It's way faster than manual labor. You can do everything all at once you have an understanding of how Regex works. It's way easier than going through entire files, searching for text, or replacing things one by one. So here are some examples of what we can do with Regex. We can match a number of different strings rather than one exact word. So for example, with LEMDO, we're working with early modern texts. We might come across a lot of different spellings of a single word, such as John. We might see John spelt with a J or an I, and we might see it with or without an H before that N. Using Regex, we can do one search and find all of these variant spellings. And then once we've found our string or our bunch of strings, we can replace part of it while retaining the rest. That's what happens in that find and replace that I showed earlier. We remove the facts attribute, but we retain the PB element. We can also do things like replacing the value of unit attribute on the space element. So maybe we have a file that inconsistently uses the char, the M, and the CM values. We want things to be consistent throughout. So we could search for all of that and change it to the char value with just one click of a button. So then throughout your entire file, you're consistently using the same unit for your space elements. We can also change the order of things. So if we want to standardize the order of attributes on the ref and pointer elements, so that type always comes before the target attribute, we can do that. It's nice to have things consistently encoded. It makes a big difference when we are searching for things. And so it's nice if you can make them all consistent if they're not already. Now, Regex does have some limits. You can't use it to do your editorial work. And for those of you working with the DRE editorial guidelines, you might notice that it explicitly says not to use find and replace to do your editorial work. Hopefully that makes sense to you. You as an editor are making scholarly decisions about what to do on a case-by-case basis. You wouldn't want to go through your file and search for any spelling of the word would and change them all to WOOD. That would be taking away your editorial job, your scholarly work. And it's not the way to do things. Instead, you would need to look at each case individually and decide how to modernize the spelling of the word would. You might choose to use a regex to find all spellings of the word would, so then you can look at it throughout your old spelling text or your semi-diplomatic transcription, and then look at each instance on its own and decide what to do. But you wouldn't go ahead and replace them all at once. The other limit that I'll mention is that regex isn't going to find what you're looking for if it's in a different order in the encoding versus your find box. So, for example, if you're looking for all of the stage elements that have both type and place attributes, and you put the type attribute before place in your find bar, but you're encoding sometimes places before type, you're not going to find those ones. That's why consistency in encoding is really important. If you need to batch change something down the road, it's way easier if everything is encoded consistently in the same way from the get-go. As I mentioned, you can change the order using regex if you need to, but if you encode things consistently from the beginning, it's much simpler. So hopefully we're all kind of excited about the potential of regex now. Let's talk about some key characters. Starting with square brackets. When we type square brackets into our regular expression, it's going to look for any of the individual characters inside of the square bracket. So for example, if we have this expression where we type an I and a J in square brackets followed by OHN, we're going to be finding John, spelled either with an I or a J. So we'll find both variant spellings. And this is where I'll ask you to join in via the chat, or if you'd like to just speak up, you sure can. We'll try it out here. I'm going to have you think of what we would put into our find bar if we wanted to find these two spellings of worm, either with an O or a U. And I'll give you a second to put that into the chat. Totally. Yeah. Yeah, I'm seeing it come in. So we've got W and then square brackets with an OU inside and then RM. And that's going to find either of these two spellings of the word worm. Now, let's say we had two full words that we wanted to look for rather than two individual characters. We can use a pipe character to do that. The pipe character, this straight up and down line, is going to look for all instances of the thing before it and also the thing after it. So for example, if you wanted to look for, all instances of the words big or small, you type each of them out with a pipe character in between. Now, you'll notice that I've wrapped these into parentheses. We just want to group all of the characters together into one word. Remember that computers, although we give them a lot of credit, they're not all that smart in a lot of ways. It's not thinking about this as words. It's processing individual characters. We as humans are the ones that are giving them the meaning of words and grouping them together like that. We've got to make it really explicit for the computer to kind of understand what's going on here. So we want it to process these characters, BIG for big and SMALL for small, as groups. So we put them into parentheses here. So this parenthesis big, pipe, parenthesis small, will find all instances of big and small. Once again, let's give it a try. What would you type as a regular expression to find all instances of king or prince? Which might come in handy if you're looking at a play where Henry IV, where Henry V goes from being Prince Hal to King Henry. Yep, awesome. I am seeing it come in. We've got king in parentheses, pipe, and then prince in parentheses. And I see somebody's put exclamation because they're not sure where the pipe is. If you look on your keyboard, assuming you're using American style keyboard, it is going to be by the back backslash, right beside your apostrophe. Yep. Can you use a wildcard with the pipe? Oh, you could use a wildcard. So it would be like BIGG or SMALL potentially, I believe, is what that asterisk would do there. But you certainly can combine things. Now, let's say we're not entirely certain what we're looking for, but we know that the thing is a letter. And where this comes up is when you're looking for values in your encoding. For example, you know that the value of a type attribute on a stage direction is going to be comprised of letters such as in entrance or exit, but you're not sure, which one it's going to be. You just know that it's comprised of letters somehow. Regex has a solution for that. We're going to type our square brackets to say, look for something that's inside of these square brackets, and then just put in lowercase a dash z. This will look for any lowercase letter because you'll remember we're using the square brackets to look for an individual character, but now we're just giving a span rather than a list. So if we type C and then in square brackets A through Z, LL, we're going to find words like call, sell, and cull. And we'll also find non-words like CBLL or CZLL because it doesn't know what letter, it just knows that there will be a letter. And it will specifically be looking here for a lowercase letter because these are lowercase inside of the square brackets. So what would you type if you wanted to find dog, cog, or fog? Um, I see a question. So the asterisk in regex actually is modifying the letter before the asterisk. We'll get to it in a second, but it would say there are 0 or more of that letter. So C asterisk LL would find CLL or just LL, which is kind of weird. We'll also look at how to put in like a wildcard for letters. And I do see answers coming in the chat. All of them look great. A through Z, OG. That's going to find all of those things. And it will also find any nonsense words ending with OG. Uppercase A through Z, it's the same thing. It just is using uppercase instead. So if you have uppercase A through Z in square brackets followed by ACK, you'll find back, lack, hack, and zack, all with uppercase letter. If you don't care about the case of the letters, maybe if you're searching in a bibliography and you aren't sure if a title will have a capitalized first letter or not, you can use lowercase a through z, uppercase a through z. Now, this will still find any single letter, but it's now looking for both upper and lower cases. I'll be honest, this is not my preferred way to search for any letter. We'll get to that in just a minute, but it certainly is a way, it's an option that's available to you. I just find that it takes a while to type, and I'm using regex because I want to be speedy like Sonic. In addition to finding letters, you can find any single digit. And we do this by typing \D. This is going to find any digit 0 through 9. So 14 \D will find any number from 1400 through 1499. I'll have you try it now. What would we type if we're looking for any year, any last year of any century? So, 1199, 1499, 1999, and so on. Yeah, exactly. So we've got \D because at least for the next long while, we've got 2 digits at the beginning here, at least starting from 1099 on, I suppose. We've got \D followed by 99. Now, this is my preferred way of finding any letter, but it also is going to find any number or an underscore. So this is what we call a word character in the regular expression realm. It's a letter, a number, or an underscore. This is really useful. It's a lot shorter than typing A through Z. And it's helpful when we're doing things like looking for XML values. An XML might have all three things. It might have a lowercase letter. Let's say we're looking at the modernized folio version of Henry V. That's going to begin with the lowercase letters EMD. It's then going to have the uppercase H. It's then going to have the digit 5, an underscore, and then 2 uppercase letters, FM. Any of those things can be found using \W. We'll find one of any of those things. So if we have play \W, we're going to find plays, play 1, play 2, and so on, and also play underscore, which is really handy. We can find spaces as well using \S. Well, we can, of course, just type a space into our search box. Using this makes the space more explicit. I find it really helpful when I'm trying to move things around to have literally everything very easily visible so that I can group things together and just pick them up all together and move them around. So I tend to replace any space with a space character. We can also use it in combination with things like the asterisk or like the plus sign. And that's going to find larger white spaces that we want to close up, such as like just a return. Even when we're looking at single space, so I do find it helpful to clarify. And I saw a question in the chat come in about word character. So in this case, play \W won't find player. And the reason for that is there's only one \W. This will only find one character, but we can use it in combination with our asterisk or our plus sign to find the word player or players, or playful if we really wanted. So using it in combination with other characters, yes, it will. On its own, no, it won't. Hopefully that answers the question. The last character to look at before we get into the combining characters is the dot. Now, with regular expressions, we can have dot match all, meaning that the dot or the period symbol will match with any single character, letter, digit, space, or punctuation. This is obviously quite a powerful tool, and it makes it easy to search for and change opening and closing tags of an element, regardless of what's in the text note. But we do want to be very judicious with our use of the dot. It's what we call a greedy option, in that it will just select everything where it can. And there's a greater chance of accidentally replacing things that we don't want to with this because it will match with anything. So as often as possible, use the other options available before you use the dot. That's not to say don't use the dot, ooh, too scary. No, it's a fantastic tool, but when you can use the word character or the space character, those are also great tools that have a slightly lower chance of accidentally replacing things you don't want to. So those were all of our specific characters. Now let's expand on that. And I know that we're all very excited to get to our asterisk, which is going to look for 0 or more of a certain character. So this is a little bit different from, how asterisk is sometimes used as wildcard, because this is modifying the previous character in our string. So in this example, we have HAL asterisk, and the asterisk is just modifying the L. So this will find ha, hal, and hall. And it would also find hall spelt with 14 L's if you really wanted, although you're unlikely to come across that. So if you wanted to find Henry V with or without a space, what will you do here? And you might remember our space character is our \S. This one's not coming in on the chat. Oh, here we've got one so far. Great. Yeah. Yeah, so we've got coming in the name Henry, Henry, \S for our space character, and then an asterisk saying there's 0 space characters or more than one space character. So we've got Henry, there might be a space, and then we have V. And you'll notice we've got the space character followed by the asterisk because the asterisk is modifying that S. Now, quite similar to the asterisk is the plus sign. This is when we know for sure that something will be there. We're just not sure of how many, or we want to match with any possibility. So there's at least one, but there might be more. If we take the same example, but we're switching out our asterisk with a plus sign, we're still going to find Hal and Hall, but we're no longer going to find Ha because we're using plus and it says there must be at least one L in what we're searching for. Now this one's, again, a little bit more complex. If we have a type attribute and it has any value in it, how are we going to find that type attribute? So let's say we have a type, maybe it equals exit, maybe we have type equals entrance. We could find either of those things with one search using the plus sign. How might we do that? And I can go back to the specific characters if that's helpful. Yeah. I'm seeing it start to come in the chat. So the one thing here, generally, yes, correct. You do need a backslash before the W to get it to take on its role. So if we go back in here, we'll remember that \W is going to match with any letter, uppercase or lowercase. And it would also match with our numbers or our underscores if we needed it to. Here we only really need letters. So you could also use A through Z if you really wanted. But once we've put that \W, we can add a plus because we know that there's going to be at least one letter in this value. Does that make sense? Are there any questions here? I think this is the part where it starts getting a little bit very exciting, but also a little weird. So the W is because we know that our value is going to have letters in it. And I'm going to see if I can pause my share, or sorry, stop my share for a second. I'm going to open up a whiteboard. Hopefully this will work. Okay, so when we have a type, oops. When we have a type value, we know that it's going to have type equals and then quotation marks. In here, we're going to have a word of some sort. On a stage direction, the type of stage direction might be an exit, might be an entrance or a sound or whatever else it might be. We've got a lot of potential values that can go in here. Type, we know that it's going to be there, so we can just explicitly type that word. We also know that the equal sign is going to be there, so we can explicitly put in the equal sign. Same deal with the quotation marks. We know that those are going to be in there, so we can explicitly put them in. This exit is where we might need to match with something else, because we might need to match with entrance, we might need to match with sound or whatever else. So we can match with these in a couple different ways. These are all letters, so we could match using A through Z. And that would match with any one of these letters. You could also put, if you're feeling a little nervous about exactly what case these will be in, A through Z, A through Z. Within the LEMDO ecosystem, I don't think we use any uppercase letters for our type values, but just in case, you could put that, and that would also match with any of these letters. I tend to use \W because it's still going to match with any of these letters because it's a word character. So that's letter, digit, or underscore. And so if we put \W plus, it says, we're not sure what the letter will be. It could be an E, it could be an X, it could be an I, it could be a T. And there will be at least one letter, and we suspect there will be more than one. Does that make sense? Why the W? Yes, perfect. No, I wouldn't recommend doing dot plus. You would also need to add a question mark in there to stop the search. You could put dot plus question mark, but you would want to be very careful to check that you're matching with what you want to match before you run any replaces. So dot plus quotation mark without the question mark would find the first instance of type, and then it would just match one match throughout your entire document and end at the last quotation mark in the document, which probably isn't what you're looking for. Putting the question mark in says, stop at the first instance of a quotation mark. So you would match with everything correctly then, but you do have to put in that extra checking. But yeah, it would also find what you're looking for, dot plus question mark. Okay, I'll go back to sharing my screen. There we go. And let me pull my chat back open again. Perfect. Okay. So we got our W plus, and that's going to find any single value on the type attribute. Now, let's say we want to modify a bunch of characters with the asterisk or with the plus sign all at once. We want to create a group. And this is where it starts to really feel mappy, to me at least. This is where we start using parentheses. We can also use parentheses to just mark out groups of characters that we want to keep during replaces, but we'll look at that in the next section of this presentation. Right now, we'll just focus on using parentheses to modify a number of characters. I've put this example here. King \S\W plus. And to parse this out a little bit, we know that we're looking for something beginning with the word king. We have \S, which would find a space, followed by \W plus. So one or more letters, digits, or underscores. All of this is in parentheses to mark it out as a group, and it's being modified by the asterisk. So the asterisk is applying to this group altogether / word character. All that is to say, we're looking for the word king, and the word king may or may not be followed by a space and then one or more word characters. And then I've also put the word said here. So there could be one or more words before the word said. So this is going to find king said. Let's say you were looking for the king said. Because the asterisk says there could be 0 spaces and word characters before the word said. That's going to be kind of the simplest find. We're also going to find King Henry said, because we have the word king, we have 1 space character, then we have more than 1 word characters, HENRY, and then we have our word said. So King Henry said is also going to be found by this search. King Henry once said would also be found by this search, because we've said they're going to be 0 or more. So there could be an unlimited number of words before we get to the word said. It could also say King Richard III, King Richard III once said, assuming that it's typed like so, because we're using the word character. You'll remember \W matches with letters, but it also matches with digits. So it's going to find this number 3. It will find all of those, any number of words between the word king and said, unless there's punctuation in there. So if you had, the sentence ends and then in another sentence the word said shows up, it's not going to match with that, because this W is not going to match with any punctuation other than an underscore. But it will find all of these. It wouldn't find the king said, which is in the chat, with the reason being king in the chat has a lowercase k. If you wanted it to find either the king said with a uppercase or a lowercase, how would you do that? This is bringing us back to the beginning of our characters here. It's bringing us back to our square brackets. Anybody want to hazard a guess? Yeah, exactly, Maureen. So you can have your square brackets and have a lowercase k and an uppercase k, and then it will match with that. And you could add that in to the example here with a square bracket, uppercase k, lowercase k on king. And that's then going to match with the king said as well. And that's just an example. Sometimes it takes a couple of tries to get your regex to match everything that you want. Jesus, that would also work perfectly well. You could put in brackets, uppercase K, pipe, then lowercase k. Because it's just one character, you don't necessarily need the brackets, but I tend to put them in just for clarity anyhow. I like things to be very explicit in my regular expressions. It helps me find where I make mistakes because it does happen. Yeah. You could also put, if you really wanted, \W before ing, but then you might get things such as the ring said, although I don't think that's likely to come up. Now, the last one that's helpful to know is you might be thinking, uh-oh, I'm going to run into some trouble if I want to find any of these special characters, like a period, or you actually want to find an asterisk. Not to worry, Regex also has a solution for that. We can use the backslash as an escape character, meaning that if we want to find one of those special characters that we've gone over, I can use a backslash first. So, for example, if you wanted to find like actually a period, backslash period is going to find that. For the characters like \W or \D, you don't need to do \W to get out of there. Just type W and it will find a W. Okay. Now I'll pause for just a moment for questions. Is there anything coming up right now? I know that is a whole lot of learning almost new language skills. Yeah.
I'm still stuck on the asterisk.
Mhm.
Or you had HAL asterisk, and I thought it was the previous character, so that would modify the L, but I'm not sure how we get to the HA.
Yeah, so the asterisk says there could be 0 of the previous character as well.
Oh, okay.
Yeah, so that's the difference between asterisk and plus. Asterisk says there might be 0 of this character, whereas plus says there will be at least 1 of this character.
Okay, yeah, I think the way I thought about it before was always as an additional, so that's 0.
Yeah.
Got it. Cool.
Yeah.
Thank you.
It's a bit of a funky one. That's a great question though, yeah. Okay, is there anything else coming up? Yeah, the difference between letter, digit, and word character. For sure. So when we're thinking the difference between a letter, a digit, and a word character, it's really based on what you want to find. A letter you would find by, if you only wanted to find letters, you didn't want to find anything else, you would do in square brackets, A through Z. If you're looking necessarily for lowercase, you would put lowercase. Specifically for uppercase, you'd put uppercase. Or if you're looking for either, you'd put both a lowercase A through Z and an uppercase A through Z in square brackets. And that's only going to match with letters, which is helpful if you want to find Henry V, but you don't want there to be an underscore between Henry and the uppercase V. A word or a digit character, I'll say next, is \D. And that's going to be any digit. So 0 through 9, \D will find. Again, that's helpful if you know that what you're looking for is a number. Like you're looking for a year or you're looking for a paragraph XML ID and you know that it's going to end with a number. We'd use a \D then because it's specific. You would use the word character \W if you were open to finding any of a letter, a digit, or an underscore. It's shorter than typing A through Z, A through Z. So I tend to use it when I'm looking for letters as well, if I know that I'm unlikely to match with numbers. But it will find a letter or a number or an underscore. Any of those count as word characters. Does that make sense? Or does that answer the question? Yeah, okay. Is there not an operator for characters? Can you define operator for me? This is where I reach the limits of my knowledge. Yeah, digit is only numbers. I'll wait to see clarification on the KK, but not L. If you search for K and K, it won't find L. I believe you can do not in some cases by using a, I don't think that you can actually for that. You could put a backslash uppercase W would find not word characters, and same backslash uppercase S would find not a space. You might be able to do not L like that, but I'm not sure how that would work or not. Oh, sorry, that would be, no, that would be incorrect. Ignore that last one. I'm not sure, Matthew, actually. I think you can, but I can't remember off the top of my head. A range of characters, but not Q. I would need to look it up. Yeah. Thanks for that really good question. Now I'm going to be diving into my cheat sheets afterwards. Okay, so let's look at how all of these things actually come together. So in this section, we're going to talk a bit about parentheses for replaces. We're also going to learn a new character that we use for replaces and kind of put it all together. So if we return to parentheses, you'll remember that I said we can use parentheses to keep groups of character during a conversion. That's what we're going to do now. So we can use parentheses to create what we call back reference groups. We aren't modifying these groups using the asterisk or the plus sign, and the parentheses have no impact on the find part of the process. So I've put an example here. We're using parentheses to create a group around this section and another set to create a group around this section. And I'll zoom in on what that is because that's a little small. So here's the same regex outside of the find box. And I don't think I mentioned, this is what our find and replace box looks like in Oxygen, which we use for our encoding. So I use that to show example of what it will look like when you do it. So this is that same regex, just a little bit bigger. We use it in the LEMDO environment to find PB elements that have an N attribute with an inferred page number, followed by a semicolon, a space, and then a signature number. I've just put an example of what that looks like beneath the regex because I think that this at first looks a little unapproachable. But we'll walk through this one to kind of parse it out. So we begin off with the PB element. We have our opening bracket. We'll ignore the parentheses for now. We have our opening bracket, the PB. Then we have one space before we get to our attribute, right? That's a space here. I put in \S because I like to see things explicitly. Then we have our N attribute. We know it will have an equal sign. We know it will have quotation mark. All of that is in parentheses because we want to keep it. We don't keep inferred page numbers, which I've put in as a \D+ because we know that an inferred page number would be, at least one number. It might be page 1, it might be page 10, but there will be at least one number in there or one digit in there. And then we have a semicolon. There was a point, I think, when the initial conversions were happening for lots of our files where there were inferred page numbers, and the format that they followed was the number followed by a semicolon, followed by a space, and then the signature number. So this is just that number, semicolon, space. Then we have our second back reference group. And this is the other part that we want to keep. It's the signature number. And signature numbers are almost always, but I will say almost because I know that there are exceptions to this. They're almost always going to be formatted letter, number, and then letter. For example, you might have signature number A1V for the verso of your A1 page. And a W is going to find all three of those because \W is our word character. It finds uppercase letter, it finds numbers, and it finds lowercase letters. And we've put a plus because we know that there's going to be more than one word character there. So there's these two back reference groups. This is the first one, and this is the second one. These will get mechanically numbered by the find and replace processor. We won't see the numbers, but the numbers are important for our replace. We can figure out the numbering on our own because the first group of brackets is number 1 and the second one is number 2. And Kristen, yes, it wouldn't find the period space after sig. So the plus won't include spaces. If you did S plus, that would find one or more space. We haven't found a lot that have sig before the signature number, but if you were working with a play and it did have sig followed by the signature number, like you have there, you could modify it to be \S and then the word sig, and then escape the period so that the dot doesn't match all, and then your W plus. And that would then find with sig before the signature number. Yeah, no worries. So here with our back reference groups, we count from the opening bracket. So this is opening bracket 1, which means that this group is group 1. This is opening bracket 2, so this is group number 2. It can get a bit more complicated than that, but this is the place to start. Once we know the numbers of our back reference groups, we keep them using the $sign. So a $sign followed by a number in the replace box of our find and replace is going to keep that number of back reference group. So each of them are mechanically numbered. Those are the numbers that we're using. $1 would keep back reference group number 1. $1 means we want to keep this section with no modification. So to replace, we know that we want to keep back reference groups 1 and 2. Those are our only back reference groups for removing inferred page numbers. We're going to type into the replace box here, $1, $2. This says keep. I usually just translate $sign in my head to keep. Keep back reference group 1, and then keep back reference group 2. We don't put any spaces between because we don't want to add any spaces to our XML. We have all of the spaces that we need. We can then run our replace. Now, one of the cool things that I really like about back reference groups is that we can change the order of things. So we could put $2 and followed by $1 and just reverse the order of things. That wouldn't be useful, for example, here. It would give us invalid file, but it is really useful when we want to, say, standardize the order of attributes on an element. The other thing that we can do is explicitly write things with our back references. So let's say you wanted to add a formworks element after all of your page beginning elements, FW element after all the PB elements. We could keep $1, $2, which keeps all of our PB elements with the corrected numbers. And then immediately after write FW. So you'd have $1, $2, and then FW element. And that would create a formwork right after all of your page beginnings. Now, we'll look at this in concrete steps for how to do this, and then also talk about running regex conversions safely. Because now you've got all of this power, so you also have all of this responsibility. You've probably realized there's a chance you could replace things that you don't want to replace when you run a regular expression. To make sure that you are only replacing what you want when you run conversions, the first thing that you're always going to do is, if you're planning on running this conversion or running this regex on more than one file, test on one file first. This makes it so that you can easily check for errors and not have to go back and deal with repeated errors across an entire folder. You'll also always want to click Find All before you click Replace All. Check that you're matching with what you want. Oxygen will put at the bottom of the screen all of the things that you've matched with. Make sure that those are what you think you're looking for and not what you're not looking for. It will also show you the number of things that it finds. If that is a similar number to what you would expect, let's say we're getting rid of inferred page numbers, you'd expect to match with the same number as you have page beginnings in your facsimiles. Check that number, make sure it matches what you expect, make sure that the actual things you're matching with are what you expect before you hit replace all, and that will make sure you're replacing the right things. And then of course, working in Oxygen, you're always going to want to validate your file after you do your work. So find all, replace all, and then validate. And very practically what your steps are is go in, open up your find and replace window by typing in Control F on Windows or Command F on Mac, also Control F on Linux. You'll then get this box. Make sure that you've selected regular expression. If you don't select this, none of these characters will do anything for you. Also, click dot matches all. That's what makes it so that the dot matches everything. If you don't want the dot to match all, don't click it, and then it won't. Then in your find bar, type in your find expression. Here's one right here. It standardizes the order of attributes on stage elements and semi-diplomatic transcriptions. Once you've typed in your find, click Find All, and then Oxygen will show you everything that you match with. If you're happy with that, type in your replace expression. Here, we're just changing the order of a couple of back reference groups. So we've got explicitly what we want it to say, and then 2 back reference groups, $3, $1. We've changed the order. And then hit replace all. And of course, validate. A very quick recap of what we've gone over today. You were introduced to regular expressions. Way back at the beginning of this, you learned that regex is a way of doing complex find and replace actions that's much faster than manual remediation. It's great for finding all instances of a pattern, but you can't use it to do your editorial work. You can use it to look at all instances of something before you work on a case-by-case basis. And when you're using regular expressions, as with always, consistent encoding is your friend. There are a number of key characters that we went over today. I'm not listing them all here, but you can come back to this presentation and find them, or you can look in LEMDO documentation. And you learn that you can combine characters. So \W+ is going to find one or more word characters. We talked about using parentheses to mark out back reference groups that you want to keep. Just wrap the thing you want in parentheses. We learned that each of those is silently numbered. You won't see the numbers, but you can count them from the opening bracket. $signs are used in our replaces to call back reference groups. Finally, we talked very briefly about safety. Run all of your find and replaces in a single file before you do them across an entire folder. Click Find All and check things out before you click Replace All, and then always validate. We do have a couple of resources that I'll point you towards. The first is our own LEMDO documentation. So we have a file or a page called Text Conversions with Regular Expressions. It's in, I think, chapter 23 of our documentation, and it gives an intro to regular expressions, a big mnemonics table so that you can see what each of the characters does, with far more characters than I went over today. It gives you safety tips. It gives you some helpful preformed regex. So if you're working in the LEMDO environment, some things that we find that we use frequently, and then you don't have to write it yourself, which is helpful. You can also check out regularexpressions.info. They've got quite a good bunch of information on there. Quick start tutorials for regex, for replacements, and then also some reference charts. I would also like to say thank you to the Social Sciences and Humanities Research Council of Canada for funding this webinar series. Today is one of a lot of different webinars that we're doing. You're welcome to join us for more. Thank you to me, as always, for designing these slides. Thank you to Martin Holmes for LEMDO's TEI customization, and to UVic's Humanities Computing and Media Center for our site design and hosting.
Navarra, there was a question in the chat from Jesus. Why $3, $1 in the last example?
Yeah, for sure. Let me grab that example. Here it is. So here we've got, we want type to come before rendition. So with our find, we have stage, then we have our first back reference group for rendition. And with rendition, we might have one or more values. So you might say rendition is italic and also its letter space. So instead of using a dot matches all, which I could have done, I decided to use \W+, because I know that all of our values for renditions are going to be formatted like this: RND : italic, or RND : letter space. So here's our first rendition is \W+ for RND, : \W+. That might be italic, it might be letter space, it might be normal, could be anything. And then I might have another one. So I have modified this group here with an asterisk to say there might be a space followed by another rendition, RND+ with this \W+, a colon, and then another \W+ for whatever the rendition is. And this is modified. There may or may not be this. And if I'm counting from the opening brackets, here's number 1. It begins at this \S for rendition, and it ends here after this quotation mark. Then I have the second group here, \S followed by my W's. And this is number 2. I want to keep number 2 inside of number 1, which is automatically done here. It doesn't need to explicitly be written out because it's contained by something else. Then I have number 3 here, and that's our type, which is going to be a letter. It will always be lowercase letter for stage directions. So it'd be exit or entrance or sound, so on. Plus, because there's going to be more than one letter. And then I actually have a fourth back reference group here because there might be another one. And this is missing a \s. There would be a space before the second value and an asterisk. So this one has four back reference or four groups. Number one is the rendition. Number two is contained by the rendition and it's to modify something. Number three is the type value. And number four is contained by type value and is also to modify something. I want to put the entirety of type before the entirety of rendition. So that's why I'm using $3, $1. And hopefully that makes sense there.
Yeah.
Yeah.
Jesus says, I see, thanks a lot.
Yeah, no worries.